Throughout history, we have built remarkable things from the pyramids in Egypt to advanced skyscrapers and intricate transportation systems. We have harnessed the power of engineering to create complex machines, develop groundbreaking technologies, and explore the depths of space. Today, our achievements span diverse fields, including renewable energy, biotechnology, and artificial intelligence, reflecting our incredible capacity for innovation and problem solving. But how could this all be achieved? What's the secret behind creating complex structures, machine, or even political systems? In this video, I'll show you how this simple but ingenious mathematical idea was at the center of it all, and how you can use it to solve any big problem in your life. Henry Ford, the founder of the Ford Motor Company and a pioneer in making automobiles affordable, have famously said that nothing is particularly hard if you divide it into smaller jobs. And I'm sure everyone's heard the advice, if something's too big to handle, just break it down into smaller pieces, right? But how should you do that? Everyone just skips over the how part as if it's obvious. Well, it's not that obvious. The problem is that one big task often involves parts that are dependent on one another. You cannot just do little tasks here and there and expect your big task to be resolved. But there exists a math-based secret that will allow you to do exactly that. In fact, it is so commonplace that once you understand it, you will see it everywhere, from politics to engineering to writing code. So what is this idea? It's an idea in linear algebra called basis vectors. Sounds fancy? Don't worry, it is actually quite simple. Let's start by a simple example. You have probably heard of coordinate systems. They are systems that you can define to determine the position of any points that you want in a geometric space. Now look closely. Why is it that the axes here are orthogonal to one another in order to perfectly cover or span the whole two-dimensional space? In fact, if the angle between the axes was anything but 90 degrees, you would have a correlation between the coordinates of different points in that system. So it is only by defining two vectors orthogonal to one another that we could build a system that could flawlessly cover a two-dimensional space. Now, this example was geometrical, so we could visualize and imagine it, but in fact the abstraction of the same idea is not within the realms of geometry, but in linear algebra, where the idea of basis vectors are presented. Basis vectors are simply any set of vectors that could satisfy these two properties, be independent of one another, and together span the whole target space, whatever it may be. This idea is so profound, in fact, that it is used everywhere. For example, in politics, in order for an ideal government to satisfy the needs of its citizens, it has been divided into branches of executive, legislative, and judicial. Each one of these branches is like a basis vector. They are independent, meaning that they don't interfere with each other. The president isn't supposed to be writing laws and judges aren't making policies. But together, these branches span the entire system of government. They cover everything that needs to be done to keep a country running. As long as there is no corruption, this system is balanced, organized, and nothing overlaps. Now let's switch to engineering. When designing a bridge, for example, engineers face multiple forces: wind, gravity, tension from the weight of cars. These forces are broken down into independent directions, just like basis vectors. Each force is tackled separately, but together they span all the forces that act on the bridge. This is how engineers ensure the bridge stays stable. One force doesn't mess with another. The key here is the same two ideas, linear independence and spanning. The wind force doesn't interfere with the gravity force, but when you add them all together, they span the entire system of forces acting on the bridge. This allows engineers to design structures that can handle everything nature throws at them. And then there's coding. When you write a program, you don't write one huge block of code. You break it down into independent functions. Each function is responsible for one thing only, and it doesn't interfere with the others. But together, these functions span the entire program. They handle everything your app needs to do. These functions are thus the independent basis vectors of the app, and together they span the full set of tasks your app can do. For example, one function handles emails, another handles videos, and they all fit together to build the full experience experience without breaking anything. In fact, when there is a bug, it usually means that two functions were written in a way that their tasks overlapped, because bugs are usually the result of something happening in a space that was created by different functions creating an unseen target space. As long as the functions or basis vectors are defined 100% independent from one another, then together they would cover the entire target space of the application. So whether we're talking about politics, engineering, or coding, the trick is the same. Basis vectors, they break things into independent parts that don't interfere, but they also span the whole target space. That's why this idea works so well. You get total coverage without chaos. When you break any complex system into parts that are independent but still cover everything you need, you make the problem easier to manage. It's efficient, organized, and it just works and has been working for thousands of years. So the next time you're staring at a massive problem, whether it's designing a building, writing a piece of code, or even organizing a project, remember this secret: basis vectors. Break it down into independent parts and make sure they span everything you need. It is only a simple math trick, but it can do wonders.